All right, now this is the final example we'll go through, and it's probably the most complex because of the way it's worded, but it's not actually that complex when you break it down piece by piece. It looks like it because of the matrices, but bear with me and we'll see if we can get through it. So first of all, it says to express the composition of the transformation. So that's the goal. The final goal is to express the compositions of the transformation. So our end result is going to be something along the lines of x image equals this and y image equals this. All right, so we want to know what the transformations are that are occurring in terms of image points and so forth. All right, so next step, it says we have a dilation of factor k from the y-axis, then a translation defined by the matrix this. Now you might remember that translation of matrices doesn't happen in the 2 by 2 one. Translation of matrices happens as a little 2 by 1 where you are adding it to the xy point, all right? Because translation is just a strict movement sideways or up. So this one here would be x plus 2 and y plus 1. So it would show a translation 2 across and 1 up. All right, so translation matrices are added after the dilations and so forth have happened, depending on the order. All right, so it says followed by a translation matrix AB, and then it says where it maps the point xy to the point x image, y image, all right, as a matrix equation, and it says hence find x and y in terms of x image and y image. So let's go back to our initial assumption that this was going to be our answer, and we'll flip it around and say our answer wants to be x equals something with an x image in it, and y equals something with a y image in it. All right, so I'll just erase these ones because they're not going to be what our answers are. Okay, so now, sort of understanding that, let's just start going through. We have this dilation of factor k from the y-axis. Now you might remember that the dilation from the y-axis transformation matrix looks like this. All right, this one tells you how far it's gone away from the y-axis. Okay, and we're going to multiply it to the point xy, and then we're going to add this AB translation into it, and we're finally going to spit out the answer of x image, y image. All right, so what we're being asked to find here is precisely all of this. All right, so knowing that this is our goal to get x equals and y equals, I'll show you two ways of doing it. One way is a little bit longer, but probably more understandable. The other way uses matrix equations and then simplifies things. So to start with, let's give ourselves a bit of space at the bottom here. Let's just multiply out this first because multiplication has to happen before addition. So we have kx plus 0y, and then the bottom row times the column is 0x plus 1y. All right, and then this hasn't been done yet, plus AB, and it still equals the image points. All right, so then I'm going to drop off the zeros there because they make no difference, and I'm going to add the two matrices then. So it's going to be kx plus a translation A and 1y plus a translation B, because you remember addition and subtraction of matrices just happens position to position. All right, so this equals the image, and then we can take it in basically two lines. We can split it like this, and we can say that, well, this is the x coordinate here, so this is the transformation, and this is what we're going to call it, and then the bottom one is going to be 1y plus b equals y image. All right, so again, this is the point with the transformations that have occurred to it, and this is what we call it. Now, the question didn't ask us to find the images, the question asked us to find x and y, so we just have to rearrange these two into x and y. So it's just a simple matter of saying subtract the a from both sides, so x image minus a, and then divide by k, and you'll have looking like this. So this is the new point in x equals. Do the same thing for here, which is a little bit easier because there's no coefficient of y, and you end up with y equals y image minus b. All right, so these then are your two solutions. You have x image minus a all over k and y image minus b. All right, so what we've done there, the process we've gone through is that we've just laid out all the transformations that happen. So this is the dilation from the y-axis. This was the translation. We've multiplied it through the point into this matrix here. We've added in the translation. Then we've rearranged to find out what the original values were, and they are the image minus a over k and the image minus b. All right, so that's the first way, and that's the way most people will probably feel most comfortable with. So I'll show you now the second way, and hopefully we arrive at the same answer. All right, so the key to this one is to go back to this middle step here, and I'm going to rewrite it over to the side so that we can mess around with it. So we've got k, 0, 0, 1, x, y plus a, b equals x image, y image. All right, now, we knew from the context of the question that this matrix was called C. It didn't tell us anything else. So what we're going to do is we're going to assign variables to these matrices. So I'll call this one X because it's the original. I'll call this one X image because it's the image. And I'll call this one A because random reasons. All right. Now, we have AX plus C equals the image. Now I know that to get X by itself, because that's what my goal is, X and Y equals, X by itself I have to subtract C. So I have AX equals X image minus C. Then I have to divide by A, but you might remember that in matrices or matrices there is no division. We have to multiply by the inverse. So then I'm going to multiply both sides by the inverse, which is going to get me X by itself, and it's going to give me this times X image minus C. All right, so then because this minus C happened first, you put that in brackets, and then the inverse gets multiplied out the front of that. So then my next step is to find the inverse of A. And if you remember the inverse formula, it's just 1 over AD minus BC multiplied to the front of, and let me get this right, we switch D and A and we make negative B and negative C. So our inverse should be, and remember this is of A and this was matrix A up here, so K times 1 is K, 0 times 0 is 0, so it's 1 over K, multiplied by, switch 1 and K around, so you have 1K, and the two zeros become negative, which doesn't change anything. All right, so this is our new inverse. We then multiply it by what's in the brackets here, which is X image, Y image minus AB. All right, now before I go any further, I'm going to actually simplify the brackets. So 1 over K, 1, 0, 0, K. Brackets become X image minus A, Y image minus B. Now, if you're keeping track, you might remember that looks very familiar because that's exactly what we got over here on this top line of the denominator. Then I'm going to multiply the two matrices together. All right, so this by, important to remember there, it's a bit messy, that X image minus A is one term. So when you have 1 times X image minus A, it just comes out as X image minus A. When you have 0 times Y image minus B, it comes out as 0 because it's 0 times everything. So it's going to become, we're going to have 1 over K matrix X image minus A over, and the Y value is going to be K times Y image minus B. All right, now, I've written it like that. I haven't expanded the K through it because in the next step you're going to find out what's 1 over K times K. It's just 1. So our new point is going to be 1 over K bracket X image minus A. And on the bottom it's just going to be Y image minus B. All right, so this, remember, The original thing, what was left on the left-hand side was just x, and x was the original point, xy. So we know it maps now to this matrix, which is given as 1 over k x image minus a and y image minus b. So compare that to what we've found over here. X maps to 1 over k times x image minus a. That's exactly what we've got here. 1 over k is the same as dividing everything by k, which is why this is just a different way of writing it. Y maps to y image minus b, which we saw over here also. All right, so two different approaches. One way probably uses a bit more time because you have to multiply the matrices through, then add, subtract, and rearrange. The other way utilizes a matrix equation where we substitute variables out for the in for the matrices, rearrange it, get it all into place before we even go near the matrices. It's arguable whether it saves you much time, but I can guarantee you that later on, with more complex examples, doing this approach will save you more time than doing this approach. All right, so I would probably advise you to start using this approach, but get comfortable looking at and understanding what we need to do for this approach. Okay, remember, there's no division of matrices, you're multiplying by the inverse, so you do have to remember this little formula here.